In this particular example, we've been asked how accurately one should measure the radius of a sphere to calculate the volume, where volume is v equals 4/3 pi r cubed, within 0.5% of its true value. This question is backwards to the questions that we typically solve. Normally, when a function's been given in this form, v equals 4/3 pi r cubed, we would normally be given dr and be asked to find dv. However, in this case, we've been given dv and been asked to find dr. There are two different techniques we can use to accomplish this. The first method is what we're going to show on these particular screens. It makes a lot of sense, however, from an algebraic perspective, it's far more challenging to do. It's very easy to make careless errors, especially when you're working with exponents. What we're going to do is take our equation, or function, v equals 4/3 pi r cubed, which is v expressed in terms of r, and we're going to rearrange it such that r is expressed in terms of v. And I've done that, and I've also done it in your study guide, and you'll notice that r is equal to 3 divided by 4 pi times v, and that's all raised to the 1/3. I don't think any of you would have difficulty seeing the algebraic manipulation required to obtain this particular function. Well, the next thing we'll do is start by stating the formula for differentials. dy is equal to f prime x dx. Well, in this case, we're not dealing with y's, we're dealing with r's, and we're not dealing with x's, we're dealing with v's, or volumes. So, when we use that formula, we obtain that dr is equal to 1/3 times 3 divided by 4 pi times v, where that is all raised to the negative 2/3, and then I multiply that by 3 divided by 4 pi. I obtained that derivative by using the chain rule. And then I have to multiply that derivative by dv. In the next line, what you'll notice is that with the first term, 1/3, we have a 3 in the denominator, and in the third term, 3 divided by 4 pi, we have a 3 in the numerator, and that allows us to do some division and obtain that quotient of 1. So we end up with a 1 divided by 4 pi times 3 divided by 4 pi, which is then multiplied by v, and that's all raised to the negative 2/3. dv, in this case, is half a percentage of the true value, or half a percentage of v, which would be expressed as a decimal as 0.005v. So we now have the expression for dr. It's not very pretty, but we do have the expression for dr. If we want to work out the percent error is approximately equal to df divided by f of a times 100. Well, using the variables that we have in this particular question, dr is going to be divided by r, and then that's going to be multiplied by 100. If you're not sure where this particular formula comes from, it's found in your textbook. There's several formulas found in there that are used in these particular questions involving differentials. On the next screen, what we've done is we've continued working out the percent error. The numerator, that is simply dr that we previously worked out. The denominator is r, which we had rearranged and found that r was equal to 3 divided by 4 pi times v, which is all raised to the 1/3. So we now have our dr divided by r and then multiplied by 100. Well, if you'll notice, we have a 3 divided by 4 pi times v raised to the negative 2/3 in the numerator, and a 3 divided by 4 pi, which is then multiplied by v raised to the 1/3 in the denominator. Those two particular powers have the same base, so I should be able to complete the division by simply subtracting the exponents. So in my next line I have 1 divided by 4 pi times 3 divided by 4 pi times v, which is raised to the negative 1. That negative 1 was found by taking the exponent negative 2/3 and subtracting the exponent 1/3, which would give me a negative 3 divided by 3, or a negative 1. I multiply that by the 0.005v, which is then in turn multiplied by 100. In the next line, all we've done is dealt with that exponent negative 1. As you know, raising something to the negative 1 merely means that you take the reciprocal of it. So we now have 1 divided by 4 pi times 4 pi divided by 3, the reciprocal of 3 divided by 4 pi, times 1 divided by v, the reciprocal of v, times the 0.05v times 100. It's then simply a matter of working those values out, and we end up with a value of 1/6%. Therefore, R should be measured with an error of no more than 1/6% in order to ensure that my volume is within half a percentage of its true mean, or its true value.